Now, our last talk of the day is on user-centered evaluation of strategies for recommending sequences of points of interest to groups. And it's going to be presented by Herzog.
Thank you very much for the introduction. So in large cities such as Copenhagen, you can find an almost infinite number of points of interest that a tourist wants to visit, like restaurants, museums, shops, and so on. But of course, time is limited, so you can never visit them all during a trip. So what a tourist is looking for is actually a recommendation that looks something like this. Most attractive points of interest combined along an enjoyable and feasible route. This is the so-called tourist trip design problem. So we've been working a lot on solving this problem for individuals, and what we have done so far is that our approach always works as follows. First of all, we collect relevant user preferences and context data. Then we collect the relevant points of interest in the area between the starting point and destination. We score them based on the data we just collected, and then we create a graph where every node is connected with all the other nodes. Eventually, we run a tourist trip algorithm which finds a path from the starting point to the destination containing some of the most attractive points of interest while not violating constraints such as time. In the past, we developed different algorithms to solve the problem. We tested them in user studies. One algorithm that we also use as a basis for this work is based on Dijkstra's algorithm, and that means this algorithm does not just find the shortest path between start and destination, but tries to maximize the score per distance. So now we want to solve this problem for groups instead of only individuals. And we tackle the problem from two perspectives. In this paper, we talk about how to actually generate recommendations for groups. And this year at UMIT, we presented another paper, which was also part of this study, where we focused more on the interaction of groups with practical tourist trip applications. So if you like this presentation, then I think this paper might be also interesting for you. Okay, but in this work, we developed different recommendation strategies for groups. They are based on related work, but also novel strategies, and tested them in a user-centered approach. So in general, group recommendation strategies can be classified into two groups. You can either aggregate user profiles, or you can aggregate individual recommendations to create a new mutual recommendation. The social choice strategies we use to aggregate user profiles in this study are average without misery, and most pleasure. Those are three famous strategies that have been proven to work quite well in similar scenarios. Nevertheless, they've never been tested in the tourist trip scenario, so that's where we implemented them in this study. The aggregate recommendations technique we implemented in this study looks like this. So first of all, we create an individual trip for every group member in a group. Then we create a smaller graph which contains only those points of interest that are part of at least one of the individual recommendations. And then we apply one of the social choice strategies again, but this time on the smaller graph to come up with a group recommendation. We developed a strategy called Connect Segments, where the idea is that every group member can visit their favorite points on a trip. So in this example, as you can maybe see, the first two points of interest are selected based on the preferences of only user 1. The next 2 points of interest based on user 2, and this will continue so on. And finally, you come up with a recommendation. And last but not least, we developed another strategy, which we call split groups. So tourist trip recommendations or sequences of points of interest have a special characteristic that people can actually physically split and consume different items at the same time during the trip, and then meet again later. This does, of course, not work with all recommendations. Think about a playlist, for example, in a bar where every visitor has to listen to the same music all the time. So how does this split group approach work that we developed? First of all, we generate a recommendation for every individual group member. And then in addition, we create a recommendation for the group using a social choice strategy. And the mutual recommendation is characterized by the solid line, and the dotted lines show the individual recommendations. You can see there's some overlapping, nevertheless they're a little bit different. And now the idea is that the group follows the mutual recommendations, because we believe the groups should stick together as much as possible. But when there is an item that is not very liked by one person, this person can replace this item by a point of interest from the individual recommendation. So now let's work with a threshold of 3, meaning that the second point of interest has a score for user 1, which is below 3, it's only 2, so it's not very good. In this case, user 3 can leave the group, visit the point of interest in the north, which is only recommended to user 1 and which has a high score, and can join the group later. So the final recommendation looks like this. Both group members in this group follow the same recommendation, the mutual recommendation, but user 1 leaves the group for a short time, joins it later, and user 2 never leaves the mutual recommendation because all points of interest are already satisfying for this user. So as explained, we evaluated all of these strategies in a user study with 3 groups. So what we did is we implemented those into the Turek Android application. We developed some time ago to test those algorithms. And yeah, you can see the split group, or one of the split group recommendations on the right. So this is how the app looked like. The users can see a list of all information in the map. And in the user study, we had groups, and every group member received an own smartphone, could enter personal travel preferences. We had up to 42 categories, such as art museum. And then the smartphones were connected. The group members received the same recommendation on all of the displays, could watch the recommendation, and then rated using a short questionnaire we adapted from the rescue questionnaire. Yeah, we worked with real groups, so people applied as groups for our user study, and we limited the group size to 3 because we wanted to reduce the number of independent variables in our study. And most of our groups were people with a very close relationships, such as families or close friends, but we also had a lot of groups with rather loose relationships, such as PS2 fellows or one example. And in the beginning we asked them if in general they think it's okay to split for a while during a trip. And as you can see, around 25% are not really happy with this idea, but the majority actually likes to split during a trip. And the interesting part is that there's no difference by group type. So even people with a close relationship told us it's fine to split for some time if this satisfies all group members. This was definitely a surprise. So the survey we used to evaluate each of the recommendations was composed of 5 statements. We were asking how well the recommendations matched the personal preferences. We asked about the diversity, about the order of items in the trip, if the trip was feasible for walking tourists, and the intention to actually use the recommendation. And which I didn't explain before, we had 3 scenarios for each recommendation. That means that in total every group got 18 recommendations, which they rated after every recommendation, and this is the average. Those are the average values. And I will do this very briefly. As you can see, the split group algorithm performs best in 3 out of the 5 statements, equally to the best strategy in statement 4 and 5. It is significantly better than most of the other strategies in almost all of the statements. Surprisingly, only the average strategy is the only strategy that performs equally well. On the other hand, most pleasure and our connect segments perform worse than the 6 group. So what does this tell us now? On the one hand, we found out that splitting during a trip can definitely improve the quality of recommended trips, especially when a group is very open to this idea. However, some people told us, even after the study, they don't want to split at all, so there's definitely no option for that. People told us that they don't think it makes sense to split when the points of interest they are visiting are very similar. So even if one person wants to see a park and the rest wants to go to a garden, they said in this case it doesn't make sense to split. And furthermore, they told us that for some activities it is not a good idea to be there alone, for example for lunch breaks or having a coffee. And this was definitely a limitation of our user study, that we work with only groups of size 3, because this means that we're splitting always one person is alone. So we believe that the split group algorithm, which worked quite well already, will work even better when tested in large groups, which we want to do in the future. We also want to find out more about which categories are actually suitable for splitting and which are not, and under which circumstances it makes sense to split. So you need some rules for that. So for example, it's obvious when you travel with a child, you can of course split in a way that the child is alone. And furthermore, when integrating all of this in practical applications, what we did for the user study, it's very important to provide user interfaces that allow groups to specify if they're willing to split or not, and maybe also which categories are okay and which are not. Otherwise, we found out if people don't like to split, the average strategy performs equally well, and it's therefore a good alternative. So now I would like to thank you all for your attention, and I hope you enjoy your drinks tonight. So you were asking if we also consider the group dynamics and the relations of agents.
Maybe action is working close. All right. The question is the issues controllability and explanation of in your recommendation. Has been any issues from the users indicating that's important, or the feedback afterwards that they miss it? They miss explanation why the hell that strange thing has been recommended. I have no idea that Mary wanted that, right?
Yeah, that's definitely a valid point. So feedback was that explanations are needed from time to time, especially when people provide a very complex profile rating a lot of categories afterwards, and they were sent to, for example, an art museum alone, while the others went to somewhere else, and then they were wondering, hey, why do I go to this museum alone? And then in this case, it would be, of course, helpful to explain them, yes, you're the only person that likes the art museum. Of course, again, then one should also consider privacy, because other people said they maybe don't want the group to know all the details, why they are blocking certain attractions or what they don't like or what they like. So it's a tough issue.
Repeat the mic was off, so repeat the question briefly. The question is, are you looking at the group, or the reverse of the problem of finding a group that'll be good for a route and not just a route that'll be good for a group?
Yeah, thank you for the question. It's a very good point. We actually didn't do that so far, but I know, for example, from the event recommendation domain, there a lot of research has been done in both ways, recommending an event to a group or finding people suitable to go to an event together. I know, of course, it totally makes sense in this case if you imagine a lot of people are also traveling alone or want to travel and meet some people while traveling. I think this is also a scenario which has a very important practical usage. I totally agree.
One last question. Okay, let us thank all these. Right back there.
Thank you. So my question would be, is there a way to rank possible routes, alternative routes? Have you thought of that?
So the question is to show alternative routes by recommending the actual route? Or?
Besides the top one route that you create?
Okay. I mean, this is possible. So what you could do is that you just basically apply the strategies that we presented, and then you take the strategy that has performed best, and you say this is the preferred recommendation, or this is the recommendation where splitting is an option, and then you choose maybe one or two of the alternative strategies and present the alternatives. Of Of course, in some situations, the root was exactly the same, because sometimes average and average can be the same. In this case, of course, you need to choose another strategy. We didn't do that so far, but it probably makes a lot of sense because people still want to have the feeling that they can decide on their own. I think this is the same for all recommendation research. So presenting alternatives is definitely a good add-on for this work.
Let us thank all the speakers again.